Good afternoon. In this video, I'm going to explain about the QR decomposition method using numerical Python, which is NumPy. So let's get started. So first, we have to import NumPy as NP because we are solving by using numerical Python method in Python. First, we are defining a function QR decomposition and passing a variable a to it. Then we are creating a matrix which is a matrix which consists of n number of rows and n number of columns. Then we are computing the shape of the a matrix using shape function, which goes like n comma n is equal to a dot shape. Then we are creating q matrix. It is an empty matrix which consists of n number of rows and n number of columns. The code goes like q is equal to np dot empty brackets, and inside that bracket n comma n and matching brackets. Since the empty function takes only one tuple, we are giving it as nested tuple. Okay, then we are creating u matrix. It is also an empty matrix which consists of n number of rows and n number of columns. So the code goes like u is equal to np dot empty n comma empty of n comma n. And we are creating R matrix, which is a zero matrix. We are creating it by using zeros function. The code goes like R is equal to np dot zeros n comma. Algorithm goes like this. The first column of u is set to the first column of a, that is u square brackets colon comma 0 is equal to a square brackets colon comma 0. That is the algorithm for it. Then to find the q matrix, we can use the u matrix, which is the algorithm to find the q matrix is u by normalization of u matrix. U by normalization of it, that is we have to take norm of u. Yes, okay. The code goes like u first column of q is equal to first column of u by norm of first column of u matrix. It goes like this, and then we are iterating it. So for I in range 1 comma n, then we are iterating the ith column of u and ith column of a. So ith column of u is equal set to the ith column of a. This is a nested for loop. So for columns we are using for j in range passing variable n. So after using for loop, the code goes like ith column of u is equal to ith column of u minus ith column of a dot jth column of q into jth column of q. So the code goes like ith column of u minus equal to a of ith column of a dot operator jth column of q into jth column of q. So to find the ith column of q, we can use ith column of u. Basically to find q, we can use u. So q is equal to u by norm of u. So we are using the same algorithm, but we are replacing it by I this time. Then we are again iterating for I in range n, for j in range I comma m. Then to find the R matrix, which is I comma j is equal to jth column of a matrix dot operator ith column of q matrix. Then we are printing the q matrix as q and printing the R matrix as R. Then we are giving the input a is equal to np dot array eval of input. Then we are calling the function qr decomposition, passing the variable to it.